All right, so you are watching this video either because your teacher was absent the day we did this lab, or you were absent the day we did this lab. So this is the Ionic or Covalent Minilab. Okay, so first question is write 3 properties of ionic compounds. So let's come over here. Okay, these 3 properties were key sentences at the end of section 7.2, and they are absolutely important. You need to know these and associate them with ionic compounds for our next exam. Okay, so ionic compound properties, they are solids at room temperature. The key sentence says they're crystalline solids, but we definitely need you to know they're solid. They have high melting points, and we talked about this one. We went a little bit further into this one, and so I'm going to do that here as well. They have high melting points because bonds must be broken, okay? Bonds, I'm going to squeeze it in here, must be broken. Bonds must be broken, okay? So high melting points because bonds must be broken. So that's pretty important, the reason. And then they're conductive as liquids, which means dissolved or melted. And again, we took that a little bit further. So these are the 3 key sentences, and then we gave some reasoning for the last 2. Bonds must be broken to melt them. Conductive as liquids. The reasoning for that is because that is when the ions can move. That is when the ions can move, okay? So make sure you get those 3 properties written down. When the ions are trapped in their solid crystal, they can't move around each other. They can vibrate in place, but they can't move from one place to another. So that's why we have to have them either dissolved or melted in order to get them to move, and that's conductivity. Okay, our second question, how do covalent properties compare to ionic properties? Okay, so we're going to come down here. I'm going to just zoom out here so you can see all of it. Covalent compound properties. Covalent compounds can be any physical state. It depends on which compound you have. So some of them are solids at room temperature, some of them are liquids, some of them are gases. They have lower melting points than ionic compounds, so lower than ionic compounds. And the reasoning for that we're going to get to in a huge amount of detail here next week. But the reasoning is we don't have to break any bonds. We're going to break some attractions between the molecules, but we don't have to break bonds, and bonds are very strong. Attractions are weak, so it takes less energy or a lower temperature in order to separate the molecules in a covalent compound. And then the final piece is they are not conductive in any form. A covalent compound, covalent means sharing electrons, okay? There are no ions, so no charged particles moving around, whether it's melted, whether it's solid, liquid, gas, nothing. Charged particles are not free to move in a covalent compound, in which case they are not conductive. Okay, now what we're going to do for the third question here is to test several compounds, and you are going to determine whether they are ionic or covalent. And conclusion below, you're going to label each one as either ionic or covalent and give 2 pieces of evidence to support your conclusion for each compound. If you need more room, there's space on the back, but we're going to call those compounds A, B, and C. So if you want to go ahead and pre-write A, B, and C, then you can get some data underneath each letter, and then you can make your conclusions after you have your data. Okay? So over here, I have compound A, white, solid, crystalline. So that would be a good thing to write down with compound A, okay? It's a white solid and it's crystalline. Compound B, white, solid, crystalline. White, solid, and crystalline for compound B. And compound C, white, solid, crystalline. So super exciting first set of data there. Everything is a white, solid crystal in our A, B, and C compounds, okay? Now behind these, I have them dissolved in water, A, B, and C. And dissolving them in water allows the molecules or the ions to move, depending on whether it's ionic or covalent. Now, if it's ionic, the ions are charged particles, which means they should be able to carry an electric current. So here I have a light bulb, and it has these 2 electrodes sticking down, and the circuit is broken. But if I put it into a solution that has ions, that will connect that circuit and allow the electricity to run through this wire, through the light bulb, and light it up. So for compound A, I'm going to go ahead and dip this into the beaker, and hopefully you can see that the light bulb has lit up. Okay, so a little higher up here, not lit, and put it in there, and it's lit up. Okay, it's a little bright in here, but okay. All right, now I'm going to take that over here, just rinse it in some water to get the substance off of the electrodes. All right, compound B, going to do the same thing, stick it in there, and it lights up. Okay, so not lit, lit. Okay, so it does conduct. A and B are both conductive. Rinse it off, come back over here, compound C, I'm going to stick it in there, nothing. Okay, again, I'll try to show you that there is no change in the light when I put it into compound C. So no conductivity on compound C. Okay. All right, our final piece of information that we had over here as a comparison was high melting points versus lower melting points. So we already did conductive versus not conductive. A and B were both conductive, so hopefully you already know what they are. And C was not conductive. So hopefully you already know what it is. But we're going to go ahead and get some data on melting points so you have two reasons for your conclusions. Okay? So